Bismillahirrahmanirrahim, dear students. This is the Pakistan International School Taif, and we are talking about grade 11. This is lecture number 21, chapter number 3 continue, and we started valence bond theory yesterday in the previous lecture, and I told you about the postulates of valence bond theory. Now drawbacks. There are some drawbacks in the valence bond theory. Number 1, the formation of coordinate covalent bond. In the previous classes you done how the coordinate covalent bond is going to be formed. I will explain after this. The formation of odd electron molecule or ions. Number 3, the paramagnetic behavior of oxygen molecules. You done in the chapter number 2, last topic. Paramagnetic and diamagnetic. So we will do in the other theory which is called molecular orbital theory. So it's just little introduction about the coordinate covalent bond. So coordinate covalent bond is formed when one atom which has an unshared electron pair, just like nitrogen has an unshared electron pair, donates to the atom ion or ion which is electron pair deficient. Hydrogen ion has a no electron, so it is going to be donate, and during this process the sharing of electron pairs taking place. That's why this name is a coordinate covalent bond. This is the hydrogen, this one, we have nitrogen, and this is the second hydrogen, and this is the third hydrogen. This nitrogen donates the hydrogen towards this one. All positive charge is created, and you will get ammonium ion. This bond is called coordinate covalent bond. So in the valence bond theory, there is no concept of coordinate covalent bond. We done in the previous classes. Okay. Now, in this theory, in the valence bond theory, the two bonds sigma bond and pi bond. How sigma bond and pi bond are going to be formed? Dear students, sigma bond, first bond ever between the two atoms is called sigma bond and is called single covalent bond. First bond ever, first bond which is formed between the two atoms, similar, maybe dissimilar, and single covalent bond is called a sigma bond. The first bond formed between the two partially filled atomic orbital is called single bond, and there is a straight overlapping between this. I will give you explanation. There will be a straight overlapping between the S and S, S and P, and P and P. The first bond, the first ever bond is formed is called a sigma bond. First. And there will be a straight or end overlapping, end overlapping, straight overlapping is called sigma bond between S and S orbital, P and P orbital, S and P orbitals. and there should be partially, as we done before, partially filled atomic orbitals. Overlapping must be in the partially filled atomic orbitals. If there is no partially filled, there will be no bond formation. So dear students, you are seeing in your book, there is overlapping between S and S. So this is the S, one S1 for the hydrogen, and there is also S, one S1 for other hydrogen. So there we are straight overlapping. Nucleus, it's a nucleus. Like this. Like this overlapping. This is overlapping. Hydrogen and hydrogen. Like this. So this is called a sigma bond. Sigma bond is going to be formed between hydrogen and hydrogen. So this single covalent bond is called sigma bond. Single covalent bond is called sigma bond. This is between S and S. Half filled, half filled. Now between S and P. So this is the hydrogen. The example I am telling you hydrogen fluoride. Hydrogen fluoride. So this is the hydrogen 1s1 plus partially filled for the p orbital of fluorine. P. Partially filled atomic orbital. If you write the coordinates, okay. So partially filled orbital of P and S partially filled for the hydrogen. This is for the hydrogen, this is for the fluorine, and they are going to be overlapped. Like this. This is between hydrogen and fluorine. This is the sigma bond formed between hydrogen and fluorine. This is the hydrogen, this is the hydrogen, and this is the fluorine P shape. P shape is like this. And between P and P, between fluorine and fluorine, straight overlapping and overlapping. P and P, yes, there is a formula of fluorine and fluorine. I told you how fluorine molecule is going to be formed. So this is same. This is one P partial orbital, 2p, yes, and for the fluorine atom, and second like this one. And this is another 2p orbital for the fluorine. There are coordinates if you want to draw. So they are going to overlap with each other to form a single covalent bond. So one overlapping. These are the coordinates. This is sigma bond between P and P, and between fluorine and fluorine to form a single. So first ever single covalent bond is called sigma bond by the overlapping of partially, half filled, partially atomic orbitals S and S, S and P, P and P. You can see in your book. So this is about sigma bond. Now pi bond. Now pi bond is formed by parallel overlapping. sidewise, sideways, sidewise or sideways, parallel, overlapping between p and p orbital, s not involved, p and p orbitals in the presence of sigma bond. Independently, pi bond does not form. It must form in the presence of sigma bond. So hydrogen only have one electron, it can only form sigma bond. There is no choice for the pi bond, no means ability. So P, maybe Px, maybe Py, maybe Pz, like this one, they can involve. So parallel overlapping between P and P of partially filled. Partially filled under this. Partially filled atomic orbitals. A bond formed between two already sigma bonded atoms. Yes. By sidewise, sideways, parallel overlapping of two half p atomic orbitals whose axes are parallel is called pi bond. The formation of pi bond of two overlapping p orbitals must coplanar and their axes must be parallel. The electron density in this bond is unsymmetrical around the bond axis. Unsymmetrical. So example is like this one. So this is P and this is also P and there is going to be overlapping like this. Above and below. There are no two pi bonds because the shape of P consists of two lobes. This is a P hole. They are the overlapping above and below to form pi bond. This is a parallel overlapping if you see your book. It has two regions of charge density above and below. I told you. The probability of finding electron is a maximum in a region above and below. Yes. Joining of two nuclei, the overlap of p orbitals, pi bond formation is not a good at sigma bond because there is no perfect, there is no proper and no perfect overlapping. But in the case of sigma bond, I told you they are diffused. S, P and P orbitals are diffused after overlapping. There is no diffusion. That's why he said that it's not a good as sigma bond. A pi bond is a weaker than sigma bond, saying one or two pi bonds can be formed between the two atoms. Just like I'm giving you example, oxygen. Two bonds, first one sigma bond. When first sigma bond is formed, then pi bond formed. Nitrogen, first sigma bond, then two pi bonds. So, if multiple bonds are there, triple bonds, then sigma bond will be one. Only one sigma bond and other two bonds are pi bonds. Lekin condition, first condition you have to fulfill that must first ever bond is a sigma bond. Yes. So these are the explanations of the sigma bonds and pi bonds. There are sideways or lateral overlapping between the p and p orbitals and perpendicular to molecular axis. The sideways or sidewise overlapping, not too efficient. So result to weak bond already we discussed, and the bond is always stronger than pi bond. Sigma bond is always stronger than pi bonds. There is a remembrance for you. Remember, in case of pi bond formation, which is over a covalent bond, the electron density is the greatest above and below the line joining of two nuclei, and this is called a nodal plane. Already we discussed in the chapter number 2. Only pure parallel coplanar half-filled p orbitals and adjacent atoms can form a pi bond. Only one bond in a multiple bond can form sigma bond, other two bonds or one bond is called pi bond. In case of hybridization, yes, we will do in this chapter hybridization. The overlapping of any hybrid orbitals always produce sigma bond. Means just I will give you, we will do detail in this valence bond theory hybridization process. So we will do three types of hybridization: sp3, sp2, and sp. So in all kinds of hybridization, the sigma bond is always formed. Applications. The valence bond approach describes bond in terms of pairing of electrons may be considered as extension of Lewis concept for covalent bond formation. The valence bond theory pictures a bond as formation from the coupling of pairing of electrons having a opposite spin, already I told you, and each form combining of atoms. It should be noted that atoms involved bond formation should have unpaired electrons, means they should have one electron in S, one electron in the P each, and they are going to be overlap. Number of unpaired electrons give rise to equal number of bonds which may be formed by any given atom. The isolated number of pairs of electrons are considered to be a lone pair if they are not participating in the bond formation. We consider as a lone pair. So example. Example of hydrogen molecule. Example of hydrogen molecule. Hydrogen, this is the H2. How hydrogen molecule is formed? From the hydrogen atom, and electronic configuration is a 1s1. This is the hydrogen. So dear students, this is the hydrogen atom, one hydrogen atom, and it has one S1, and there is another hydrogen atom, and also it has a 1s1. But according to valence bond theory, the next electron I have to put should be opposite spin. There should be opposite spin. One hydrogen atom, another one hydrogen atom, one S1 upper spin, and other hydrogen atom, one S1 downward spin. So they are going to overlap. These are going to be overlap with each other to form hydrogen molecule 1s2. Hydrogen molecule is going to be formed 1s2, and diagram already we drawn. We drawn the diagrams by the formation of sigma bond. This is for the hydrogen. If you see explanation, same. Hydrogen atom has electronic configuration 1s1. Two hydrogen atom are the half filled. They have atomic orbital and bonded between hydrogen and hydrogen atoms to form a hydrogen molecule, and this is going to be complete by 1s2, and each complete valence shell. So the electron density is concentrated in the region of joining two nuclei. The bond is called always sigma bond. So sigma bond is formed. This is the hydrogen. Okay. The second example is for the formation of fluorine. Fluorine molecule. Fluorine molecule, and you know fluorine atomic number is 9. So 1s2, 2s2, 2px, 2py, and 2pz. 2 and 2, 4. This is a 5. This is a 6. This is a 7. This is a 8, and this is a 9. Only one atomic orbital which is a partially filled to form a bond. So fluorine molecule, fluorine, this is a fluorine 1 atom, atomic number is 9, atomic number of hydrogen is 1, atomic number of hydrogen is 1, atomic number of fluorine is 9. So I told you electronic configuration 1s2, 2s2, 2px, 2py and 2pz. So 2px2, 2py2 and there is a 1 electron in the 2pz. Other fluorine atom, atom number 9, same, 1s2, 2s2, 2px2, 2py2 and 2pz. According to the rule, you have to put downward spin. Downward spin. And students, you have to overlap. There is overlapping between this one and this one, partially filled. Partially filled. So single covalent bond is formed between fluorine and fluorine, which is called sigma bond. So this is a sigma bond formed between the fluorine and fluorine. So dear students, we are going to finish here. And if you see for the chlorine and chlorine, this is same, only the orbital is going to be increased because atomic number of chlorine is 17. So when I write 17, so there will be a 2p6, then 3s and 3p. 3p involved. No difference. There will be a 3pz for one chlorine and 3pz for other chlorine. Between chlorine and chlorine, sigma bond is formed because both are in the grade in the chapter number this chapter and group number 7 in the periodic table, halogens. These are the halogens. So the same, no difference between the chlorine and fluorine structure. If you see for the hydrogen fluoride, same. Hydrogen fluoride. So this is the hydrogen. And if you write for the fluorine, this is hydrogen. For the fluorine atom, 9 atomic number here is 2pz for the fluorine. Yes. 2pz for the fluorine means 1s, 1s2, 2s2, this is 2p/2 and this is 2px2. Like this one. 2, 2, 4, 6, 8 and 9. So there is the overlapping between fluorine and fluorine. This is a fluorine. This is the hydrogen, this is the fluorine, and sigma bond is going to be formed. Overlapping between 1s1 for the hydrogen, 2pz for the fluorine. This is the hydrogen fluoride. The structure inshallah tomorrow I will start, and then I will start multiple bonds. How multiple bonds are going to be formed by using a valence bond theory. Thank you very much. We continue inshallah next lecture number 22.